Hello, we're going to look at the product rule today, and this is topic 2.8 in the AP Calculus curriculum. 2.7 includes some memorized derivatives that I'm just going to throw in with this. And if you need to print a sheet to follow along, take notes, you can go to this bit.ly link at the bottom right here, and it is case sensitive. So let's talk about the product rule, and this is a differentiation technique that you use when you are multiplying, which makes sense, the product rule, two functions that have x's in them. So any function in the form f of x times g of x is one where the product rule could be used. And so a few examples where the product rule could be used is something like y equals e to the x times x squared plus 4. And in that case, if you really want to define the two functions as f and g, you could say that for this one, like f would be the e to the x function, and g would be, that's a funny g, would be x squared plus 4. And another example, actually, I'll just go ahead and unveil all of them. I don't know why I'm doing this one at a time. Here we go. Ta-da! Okay, so we have all of these. The number 2 here, we have x cubed times sine x. That is a product of two functions of x. One of them is x cubed. The other one is obviously sine of x. Here we have x squared minus 7 and x squared plus 2, where if you wanted, you could say that f is x squared minus 7, and g would be x plus 2. And I'm going to come back to that one in just a second. And the last one, sine x, ln x, that is two complete functions of x, where f would be sine x, and g would be the natural log of x. And back up to number 3, I'm going to emphasize one word up here. I said these are examples where the product rule could be used. Just because you can use the product rule doesn't mean you need to every time. And while I could product rule number 3 here, it is going to be easier to just expand. So always be on the lookout for things that you can do to simplify and change your expression to something that's easier. And if you did expand that one, it would be x cubed plus 2x squared minus 7x minus 14. And by expanding, I've taken this from a product to a power rule, which is significantly easier. The product rule is kind of cumbersome when compared to the product to the power rule. So always be on the lookout for something like that. As a matter of fact, that is my next little, oh no, it's not, I'm sorry. I'll get to that in a second. Okay, so the product rule. So once you identify that you have a function that needs to be product ruled, and again, I'm going to look at these. If you look at the other 3, e to the x, x squared plus 4, numbers 2 and number 4, those cannot be simplified. You cannot eliminate the product rule on those. On number 1, you could distribute the e to the x, but then you would have x squared times e to the x plus 4 e to the x, and x squared e to the x is still a product. So when the product rule is unavoidable, you have to go through this cumbersome process. And I say cumbersome, it's really not that bad, but this is your product rule. So if y is f of x times g of x, then your derivative is f prime g plus f g prime. You just do the derivative of one function at a time, and you add the pieces. Because it is addition, because you're adding these, and because you're multiplying the f prime g and the f g prime, this is a forgiving rule, because you can do f g prime plus f prime g. So it doesn't matter which one you start with, as long as you differentiate only one piece of the product at a time and you add all the pieces. And when we get into more complex differentiation rules, you very frequently will see it shortened to y equals u times v, where u and v are both functions of x. And this is the exact same rule. It's just a little bit quicker to write u prime v plus u v prime. So there's your product rule. I'm going to do a few examples of the product rule in just a minute. But first, always remember that if you can use algebra, if there's anything you can do algebraically to clean up your function, do that, because it can make the derivative a lot easier than having to do that product rule. And here we have 2 examples that are products as written. We have x squared plus 2 times x minus 3. You can product rule that, but it will be significantly easier to expand that. That'll be x squared, x cubed minus 3, x squared plus 2x minus 6. Now my derivative, we can go back to the product rule, to the power rule, and the derivative would be 3x squared minus 6x plus 2. The 6 would zero out. Number 2, it is a product. However, it would be easier, in my opinion, to rewrite root x as x to the 1/2. And now I can distribute the x to the 1/2. And yeah, there are fractions, and we have to add 1/2 plus the 1 here when I distribute that. But I still think that's easier than going through the product rule. So y, my original function, as I distribute, would be x to the 3/2 minus 5x to the 1/2. And the derivative, y prime, would be 3/2 x to the negative 1/2 x, there we go, minus 5/2 x to the, that's not negative 1/2, that should be positive 1/2. 3/2 minus 1 is 1/2. There we go. And then 5/2 x to the negative 1/2. So there are a couple of examples where you could product rule, but always look for ways so you can simplify your function before you just dive into the derivative. Never just start with the derivative. Think for just a second if algebra can make your function or your derivative a little bit easier. These three derivatives are in the 2.7 section I was talking about, and I'm just going to show you these, and we're going to use these inside the product rule in some later examples. And so the derivative of sine x is cosine x, derivative of cosine x is negative sine x, don't forget that negative, and the derivative of the natural log of x is 1 over x. We will talk about those in more detail later, not today, later this year. So just memorize those for now, and we'll add to these memorized lists. Like there's also a derivative for tangent x and cotangent x and secant x and cosecant x and your inverse trigs. We're going to add a lot to this, but this is all for now. So get that, write that down, and let's look at some examples where we need to use the product rule. So we're finding the first derivative of these, and so if you really want to, you could label these as f, and this would be the g, and when I differentiate this, y prime would be the derivative of f, and the derivative of e to the x is e to the x. It doesn't look like I did anything, but I actually just differentiated it. Then we will just copy the g of x function down. We do not change it. X squared plus 5x minus 1. Then we will add to that. Okay, see, that time I just did the derivative of f. That's f prime. This is g. Now I need to do the derivative of g. So I'm going to leave f alone, e to the x, and I'm going to differentiate the g function, 2x plus 5. And so that is f. This is the derivative of g. So that's supposed to be a product. And so there is your product rule. There are things you can do algebraically to simplify that. Right now I'm focusing on just getting through the product rule, and I'm not going to do anything else with that. So we're just finding the derivative and we're looking at it. I'm not going to clean this up at all. Let's go on to number 2. We have f of x is equal to this. Now I want to, like I did before, I want to call this one f and this one g. However, since f has already been used to define the function, let's just march on down the alphabet. I'm going to call this one g, call this one h. And now when I find the derivative of f, I'm going to start with the derivative of g. So that's the natural log of x. This is the new one. Derivative of ln x is 1 over x. So I just did g prime. Now I need to copy the h. X cubed plus 3x minus 1. And now I'm going to copy the g. So I just did g prime h. Now I need to do g h prime. So natural log x and h prime will be 3x squared plus 3. And there we have our derivative. That is g prime times h plus, and then I did g times h prime. Do the derivative of one piece at a time and just add all of the pieces together. On to 3. Ooh, look at this. We have a 3-headed product. So we have y equals e to the x times sine x times x squared plus 3. And I see nothing I can do algebraically to clean that up. We have 3 very different types of functions. So we can't expand or distribute in a way that will eliminate the ugliness of this product rule. So we're going to go straight into the product. However, we do have 3 functions. We have an f, we have a g, and we have an h. One way we could do this, I'm not going to complete this, but one way we could do this would be to group e to the x times sine x and call that one big function f. And then this could be one big function g. Then if I do the product rule, when I do f prime times g, well, f prime, that itself is another product. So we have a product rule inside a product rule, which is one way to do it. However, that is a little bit cumbersome. And so instead, what we're going to do is we're just going to follow the same trend we did earlier when we only had 2 functions. And if we have 3 pieces, we're going to do the derivative of one piece at a time, and then we're going to add all the different products that we have in the end of our product rule. So I'm going to say my derivative is, and I personally like to start at the first one and just march my way down the line. So the derivative of e to the x is e to the x. Then I'm going to leave sine x alone, and I'm going to leave x squared plus 3 alone. Plus, so I just did f prime, I left g alone, I left h alone. Now I'm going to add to that, march my way down the line. I'm going to leave f alone. Now I'm going to do the derivative of the g function. The derivative of sine x, that's the new one. Derivative of sine x is cosine x, and then I'm going to leave h alone. And so I just did f, now I did g prime, and I left h alone. Well, I've done f and g, now I need to differentiate the f, so I add yet another piece, e to the x. I'm going to leave sine x alone. So I just copied down f and g. Now we will differentiate the h, which will give me the 2x. And so that was f times g prime, times h prime. And I'm adding all of this together. So the adding an extra term to the product doesn't really make it any more difficult. It just takes you a little bit more time to finish that. Okay, so now let's look into the second derivative. Well, if I wanted to do the second derivative, well, obviously, I say obvious, we have to do the first derivative first. There's no way to go straight from your original function to the second derivative without thinking about or working through the first derivative. So first, and just watch this for a second, because I'm going to work this out for a little bit, and then I'm going to erase this. If I jump straight into the derivative, this is a product, that's f times g. And if I did the product rule, I'll do f prime, that's x squared plus 5x. Leave g alone, 4x cubed plus 7. Plus, now I'm going to do g prime, so I'm going to copy the f, x squared plus 5x, and g prime would be 12x squared. And that's why, that's mislabeled. This is y prime, not y. Whoops. I'll call it dy dx. Okay, so there's my first derivative. Now to do my second derivative, I have to look at my first derivative and think, how do I differentiate that? And look what I've created. I had one product here. Now I have two products. I have a product rule here, and I have a product rule here. And so I would have to go through two complete product rules to finish the second derivative as I have it written. However, I'm not going to do that. I'm just going to put an X through that. I'm not going to erase it. I'm not going to do that because you should always think about algebraic techniques that you can use to clean up your function before you dive into the derivative. And this particular function can be expanded pretty easily. So I'm going to call this y because this is algebra. I'm not differentiating it. And we're just going to FOIL this out. Expand it. X squared times 4x cubed is 4, that's a 4, x to the fifth. X squared times 7 is 7x squared. 5x times 4x cubed, and 5x times 7, 35x. Let's see, 20x to the 4, I think, yeah, that all looks good. Now, look at this derivative. Look how clean this is. Now we just have power rules. Derivative of 4x to the fifth, 5 times 4 is 20, and 5 minus 1 is 4. Derivative of 7x squared is 14x. 20 times 4 is 80. X, 4 minus 1 is 3, and the derivative of 35x is 35. And now my second derivative, I'm going to go Leibniz again. I'm going to say dy dx. In my second derivative, Leibniz notation, the second derivative is d squared y over dx squared. And we differentiate again. So the derivative of 20x to the fourth is 80x to the cubed. 14x's derivative is 14. 3 times 80 is 240. X to the tooth. And 35 would zero out when you differentiate that. That is a constant. So always look for those algebra techniques. Never, ever, ever just jump straight into the calculus because you can sometimes make things very painful for you. So think algebra before you start with the calculus. And it's usually only a fleeting thought. We're not talking about spending 5 minutes considering the algebra. It's just for a couple of seconds. And then if algebra doesn't work, then we dive into the calculus. Okay, so let's look at number 5, and I think this is the last one. We have e to the x times 2x cubed plus e to the x plus x. And there's nothing you can do to avoid the product rule here. Don't write this down. I'm going to erase this. Well, I guess I'll just put an x through it. If I distribute the e to the x, I'll have 2 e to the x, x cubed, plus, and then e to the x times x is x e to the x. By distributing, I made this more difficult because we have two products now. I went from one product, e to the x times that. Now I have two products because I have 2 e to the x, x cubed. That's a product. X times e to the x, that's another product. So we have a two product rule instead of one. So don't expand all the time. Sometimes it's easier to leave it as it is originally presented. And so we're going to go into the derivative here. So this is f, this is g, and I'm going to differentiate this. My first derivative, the derivative of e to the x, is just e to the x. I will leave the g alone, 2x cubed plus x. Then I'm going to add to that, leave the f alone, e to the x, and the derivative of g will be 6x squared plus 1. So there's my first derivative. Now we need to do the second derivative. But before you dive into the second derivative, once again, let's pause and let's think, is there anything algebraically that can make this an easier second derivative? And I'm looking at it because right now I've got two products, and I don't want to do two product rules. I have e to the x times this. That's a product rule. I don't have to do a whole product rule for that first piece. Then I would have to add the whole product rule for the second piece, and I don't want to do that. And we can, I just spit. That was weird. We can make this a little bit easier, not by distributing, not by expanding, but we have two terms here. I have this product plus this product, and they have an e to the x in common. I can factor out that e to the x, factor out that e to the x, and when I do, I'll have e to the x times 2x cubed plus x plus 6x squared plus 1. And after I factor out that e to the x, I'll look at what's left and I see, can I add or subtract or combine anything? I have x cubed, x to the first, 6x squared, and a 1. No, I cannot. That also means these parentheses aren't accomplishing anything. There's nothing being distributed through that, so I'm actually just going to get rid of those parentheses. And now I'm going to do my second derivative. And, oh, that's mislabeled. This is not the second derivative. Whoops. Okay, so I just did some algebra to my first derivative. And by factoring out that e to the x, I went from having two product rules to a single product rule. So now when I do my second derivative, d squared y dx squared, I'm going to differentiate the e to the x. There you go. I'm going to copy my second function, which is a long cubic polynomial. Plus, I'm going to reorder that. I kind of like having my exponents in descending order, if possible, or if convenient. So there's the derivative of the first times the second. Now I'm going to copy the first function, the e to the x, and I will differentiate that second polynomial, which will be 6x cubed plus 12x plus 1. And we are finally done with this lesson. There's your product rule. I hope you enjoyed that.